Hello, good evening, everyone. Thank you for joining us to the Way Forward meetup. Today we would like to discuss some topics about code testing. We will be focusing on unit testing. In the first part of this presentation, I will show you
Hello, good evening, everyone.
Discuss some
Thank you for joining
theoretical
us to
topics.
The Way
And
Forward
then I will
meetup.
switch to the
Today
IDE.
we would like to discuss.
So I will be showing you the
about
code and
code testing
on the
we
practical
will be
examples
focusing
how
on
we should
unit
write
testing.
unit tests. In the first part of this presentation, I will show you
about the Way
some
Forward community. We provide
theoretical
platforms
topics
for software
and then I will
professionals
switch to the
discover and
IDE.
explore
So
new trends
I will
in
be
the
showing you the
technology
code
field,
and
learning from one another, get
on the
inspired,
practical
and
examples
have fun
how
with
we
fellow
should
professionals.
write unit tests. As I said, we will be
about
I will
the
be
Way
presenting
Forward
today on
community.
introduction
We
to the
provide
code testing
for software professionals
to discover and explore.
Maybe one word about
new
me.
trends
I'm
in
a
the
software
technology
developer,
field,
learning
stack,
from one another, get inspired,
I'm specializing
and have fun with fellow
in
professionals.
ASP.NET Core and
as I said, we will be
and today we will
I will be
focusing
presenting
today on
testing
introduction to the code testing.
.NET application. Maybe one word about me. I'm a software developer, full stack.
At the beginning, we will be
specializing
in
main categories
and
of testing.
Angular.
We can divide
today we will be
categories.
focusing
One is
on
the
unit
black
testing
box
of
black box testing,
and
the second one is
application
testing, white box testing.
So
and at the beginning, we will be discussing the black book testing,
the
main categories of
when we
testing.
don't know what are
can
the
divide
internals
two
of
categories.
our
One
application.
is the black book,
we
testing,
don't know the code,
and the second one is
how
white
the
box
code
testing,
exactly
white
works.
box,
But on the other
testing.
hand, we know the business logic
And,
which is behind the code.
So
we are
the
able
black book
only
testing
to test the business logic, and we are not
when
able
we
to test
don't know
what are the internal
behavior of the
our
code.
application.
In the black box testing,
we don't know the
code. We only know
how the code exactly
the business
works.
logic,
But
and
on
we
the
know
other hand, we
for
know
example, if we
the business
pass
logic,
some
which is
input
behind
data,
the code,
we will be able to
so
expect some.
we are able only
result.
to test the business logic, and we are not able to test the behavior of the code. In the black box testing, we only know the business logic, and we know that, for example, if we pass some input data, we will be able to expect some result. Okay, maybe now will be better. We had some small difficulties with the sound. I hope now it's everything okay. Okay, let me get back to the black box testing. So, for example, we have an endpoint which will be adding two numbers. So while executing a black box test, we can only pass some input data, for example, 1 and 2, and we can then expect output data, which will be number 3. And if the expected result will be exactly the same as we received from the endpoint, then the test should pass. This type of test is more domain of QA specialists or the testers who are writing automatic tests or performing manual tests and to check if the behavior of the system is according to the specification or the business logic that is described in the documentation. The second type of testing, or the category of testings, is white box testing, and this kind of test we are performing or writing when we know how exactly the internally the application is built. So we know the code, we know what are the branches, we know what exceptions we can expect. So we can test how the code will behave based on the input data and the behavior of the dependencies which are part of this the method which we are testing, or the class which we are testing. Okay, we can now switch to the next slide. So typically we can divide tests to three types. The first one is unit test, then we have the integration test and the end-to-end test. The difference between all of them is the scope which we are testing. When we test some code with unit tests, we always trying to test the smallest possible part of our application. Typically it's a class or a method inside this class. Because we are focusing only on the behavior of this class or this method, we should try to be independent of the dependencies that this method is using or this class is using. And there are some ways to achieve that, which I will be discussing later. The second type of test is an integration test, and in this case we do not focusing anymore on one element or one class. Instead, we are testing if the interdependency between those two classes, for example, which we will be testing, are working correctly. So the dependencies which we mocked, for example, in while unit testing, we will not be doing this anymore because we are testing the interaction between those two classes, for example. But the integration test term is much more bigger, because we can not only test the interaction between two classes, but also the interaction between the all elements or all of the layers that the whole application contains. And for example, the integration test can also be a test that will be testing one endpoint if we will be talking about web APIs, etc. So we don't only focusing on interaction between, for example, two classes, but also the whole application. On the other hand, the end-to-end tests are focusing on the business logic from the start of some process to the end of this process. So, for example, we can test the process from creating new user in the application, then we, for example, setting up some permissions for the user, and then we check if those permissions will allow us to do some business logic. And then at the end of this test, we should try to delete the user, delete the permission, and then we can also check if the user is still if the user is still available in the application, which should not be true. Okay. What are the main benefits of writing unit tests and the tests generally? So first of all, when you write unit test, you are verifying the code which you write. So you don't have to start the application and manually, I don't know, add some users, add some data which will be needed for you to test something. You can write a test that will try to check if the code which you write is working according to the expectations, according to the business logic or the user story, the task which describe what should be implemented. So you write some tests that are verifying if this is the code is running according to the expectations, and you also checking, for example, if the branching is working correctly, if the exceptions that you expect are being thrown, etc. The second benefit, which you gain from writing unit tests, is documentation, because usually you while writing any unit test, you are using appropriate naming conventions for the methods that are tests. So the naming convention for the test should indicate what this test is doing, what is the state of the business object at the beginning of the test, and at the end what should be result of this test. So you are documenting the business cases or the use cases of the code that you just wrote, and those business cases should be in sync with the acceptance criteria or the user story which you are implementing. The next benefit of writing unit test is regression, because you are writing automated tests. You are ensuring that the business logic that stands behind the code will always work as expected at the moment when the specification was created. So for example, if someone will do some changes in the application or in the code that you wrote somewhere in the future, and the test itself is written in the appropriate way, and we are testing accordingly to the acceptance criteria, then in the case when someone will change the code unintentionally or by accident, then the test should fail. And in that case, you are able to know that you did something wrong, you made some changes that will break the application. So in these terms, regression testing, that the unit test will act as a regression test, because every time you change something or add some new feature to the existing behavior of the system, when you execute the tests and check the result, you will be able to have some amount of certainty that you didn't break anything and the application is still working as expected. The next benefit from the testing, or especially in this case in unit test, is the unit test will allow you to refactor your code. In this case, while writing unit tests, you can have two approaches. So first of all, you can write some code and then write an unit tests, and then check if they are passing. And if they are passing, you can refactor the code, and you can be sure that after you refactor your code, it will be still working as expected. So this is the approach which I'm usually taking. So I write the code which don't have to be performant, which don't have to be as clean as possible. It can be messy, it can work slowly, but the most important thing is that it should work as expected, as the business logic is describing how this should behave. And then I can write unit test and refactor the code so it would look as close as the clean code rules or principles indicate. And then we can work with the some optimization if this is necessary for the application. There is also a second approach, which is test-driven development. In this approach, you can first write unit test, even without any line of code for the implementation of the class which you are just writing. And then according to the pattern red, green refactor, you can first make the test green. So you write some implementation in order to test pass. And then you refactor the code. You are checking again if the code is working as expected, if the test is passing. And then you are writing a next test, next business case, next use case. Again, you write some code. You are checking if the test will pass, and if it will pass, then you are able to refactor again. And in this case, the both tests should pass. So the behavior that you implemented while working with the first test, and then the behavior of the code with the second test should pass, and the logic is being built using this technique. Okay, the next slide. Typically, when you are writing unit test, you should be using this schema. Sometimes, if you see the code of the unit test, you will even see the comments that will indicate the section of the code that is indicating what this section of the code is responsible for. For example, we have three main parts of each unit test. Not all of them are necessary at each time, but two of them are needed to execute the test. So at the beginning, you have the arrange part. When you set up the data, you setting up the mock or some dependency that the class which you are testing will use. So you have to prepare the data and the starting state of the business object. Then there's a stage which is called act, which is the part of the code which you execute the method or the class that you are testing. And then, for example, if this method is returning any data, then you assigning this return value to some variable, which will be used for the next part, which is the assertion. The part which you can omit and sometimes is not necessary, it's arrange, but the act and assert are the necessary to test, to be able to call it a test. Because the assertion is, I think, aside acting is the most needed part of the test. Because without assertion, you cannot be sure that the logic is working as expected. So assertion is the essential part of the unit test. Any unit test that will not contain any assertion part, that will check your if the result of your function is exactly as expected or equal to expected, the test without this part is in fact not a test. The moment when the arrange is not needed is usually where you are, for example, asserting the data for null value, and you don't pass anything to the act part, to that code, to the method that you are testing, and you are expecting the exception at the very beginning of the test. This is the usually when you don't need the arrange part of the testing of the unit tests. Okay, so I was talking at the beginning on the dependencies, and that we have to be independent of the behavior that relies on that these dependencies in introducing to our application or to our class, which we will be testing. So to become independent of these dependencies, you have three approaches that you can take, or three possibilities that you can use to become independent of the code that is not internal part of the class that you are testing, but some external word, you can say. So first of all, it's you can create a stub, which is the simple object that will create some fixed data. You can create some fake that may be some lightweight implementation of the dependent object, but usually and mostly most popular is using of mocks, and the mocks are special classes, special implementations that are allowing you to define some expectations and behaviors that those dependent objects will have, And depending on what are the expectations and behaviors, the mock can behave differently. For example, you can return some data or throw an exception, etc. And the most interesting part of these mocks is that you can verify that the mock has been executed if the correct data has been passed to this mocked dependency. While the quite good benefit of using mocks is also that it's quite trivial to make them, to use them, while the stubbing and faking requires some additional tasks and additional implementation that you have to take in order to achieve the same logic. Okay, the last topic I think that before we will switch to the code is some insight how to write testable code. So the most important part of writing testable code is sticking to the solid principles. Of course, all of them are always necessary, but in case of on writing unit tests, the most important is dependency inversion. So we should the code inside the class should be dependent on some abstract interfaces instead of real implementations. So when we will have, for example, some interface, the mock will be able to mimic this interface without writing any implementation, while if you would not use the interface, you can still mock the class, the solid class or the original class, but for example then you have to also take in mind the dependencies of this class which you are trying to replace with some fake object. So the second most important, topic when we are talking to writing the testable code is to be very careful about creating instance of the object. When you try to create a new instance of the object inside the class that should be testable, then you are not able to pass this instance or to replace this instance with this faked or mocked implementation. So in order to write testable code, you should avoid using the new keyword inside the method or inside the classes. Instead, you should rely on techniques like the dependency injection container that should be creating instances of the classes for you, and all of the necessary code or necessary dependencies which will be your class will be using should be passed inside this class constructor. So no dependent object should be created inside your class. Another topic is hidden dependencies. Usually, for example, it's when you are trying to set the date for some data, you are using the datetime UTC now or datetime now function or the property of the datetime object or the class. This is an example of hidden dependency, because if your business logic relies on this datetime now execution, then you are not able to test your code, because this dependency is hidden from the outside world. And in order to properly test the behavior of this of your code, you should not hide the internals or the behavior of or classes, your, I don't know, branching, for example, from the outside world. The same will be for using the singleton pattern, for example. If you are retrieving the instant of this singleton directly in the code, instead of receiving the singleton from the constructor and from the dependency injection container, you are introducing some hidden dependencies that you will not be able to mock, and because of that you will not be able to test your code. Okay, some practical examples. Okay, so we have some implementation of web APIs, and this way web APIs have some CRUD operations, so read, write, delete, etc. And so this application contains at least 3 layers. First of all, we have the controller, then we have the service, which is executing the business logic. Some repository, which is responsible for the data layer, responsible for storing the business object inside some kind of database. If we look, for example, for the code that is responsible for retrieving the house from the database, we can see that at the beginning we have some assertion. Then we are retrieving this object from the database, from the store, and then we are returning the data. And if the object has not been retrieved from the database, for example, because there is no house with the ID that has been queried, then we are receiving some exception. And if we look at the dependencies on this class, we can see that this class is dependent on the repository and some mapper. Okay, so when we will try to test this implementation, we will be writing some tests that at the beginning should try if we receive this argument exception, if the ID which is passed is empty, then we should write some test that will try to check if we are using this repository to retrieve the data, and for example, if the ID which is passing to this dependent class, dependent object, is the one which we are passing to the method itself. And then we can test if the method will throw an exception if the repository will not return any data. For example, if it will return null. And the last test that we should write is to check that the data which we received from the method is the one we expect. So when we switch to the testing class, So maybe first of all, I will show you how the testing class usually looks like. So first of all of the dependencies that this house service is using is mocked. So we are using the mock library, which is helping us to implement some fake object instead of the repository. Okay, so when we are using the mock library from the .NET, we should first of all create new object, new mock, and then this mocked implementation of our interface sorry. Okay, sorry. I was showing the code without showing the code. I'm sorry. Okay, so I can go back to the house service, which I was describing before without showing the code. So we have a class, which is a service, which contains some business logic, and the class is dependent on the repository, and the repository is a layer of our application which will give us access to the database. It's an abstraction layer for the database, and then as you can see, this abstraction layer is implemented or passed here into the house service constructor as an interface, which is mean that we are not relying on the concrete implementation of our repository, but instead we are relying on some abstract interface, abstract polymorphic interface in our code. Our getHouse methods inside this service is just simply retrieving the house from the repository, and it's asserting some input data, and then if the house was not found in the database, it's throwing exception, key not found exception, while if the data was found inside the database, we can then return those data from the database to the user, while in between mapping the entity or business object to the API or DTO object that the user can see. When we will go to the testing class, we will see that we have something that is called mock. This is exactly the way which we can mimic the behavior of dependent object that is used inside our house service. So we will not be testing real implementation of the database, real implementation of some repository which will be storing our data, but instead we are replacing this dependency with a mocked object. The one interesting thing about mocked object is that when you are trying to create new instance for the house service which you would like to test, you have to pass the property which is called object, and this property will contain this fake mocked implementation of our repository. Okay, so when we will go to the test itself, that is testing our endpoint, we have testing method, our test. And as I told you before, we are using some naming convention, and we are indicating that when we are trying to retrieve the house by ID, we should throw a not found exception when house not found was not found. So we are setting up the expectation for our mock that when we are trying to retrieve the data from the database using the get method on the repository, same as here, when we are trying to retrieve use the get method inside this real implementation of the repository, instead of trying to execute the query on the database, we are saying that when user will try, or the programmer will try to execute this action, we should return the list of houses, for example. And then when we are executing the code which we would like to test, we are passing some new GUID, which will definitely not be inside our database. Then we are create assertion, or defining the assertion that when you try to execute this get house by ID method on the house service using this new GUID as a parameter, you should expect that this method should throw not found exception, key not found exception. And you can also test using the assertion mechanism that the exception that you received from executing this method contains some additional information like the stack trace, the message which we passed inside this exception, or defined inside this exception. So each time when we define the test, when we are using the XUnit testing library, we are defining some facts that the code is behaving accordingly to the test case that we defined. And for example, we can also create some bunch of tests that will not test only one business case, but also some more business cases. We can define some collection of the data which will be used as a testing data for the method to execute while running the test. And then we are using the keyword or attribute theory, and then we are passing the data, the set of data that will be used to pass to the testing method that will test our code. And in this case, we are testing that when we pass some existing data inside the method getHouseById, and we here mocked or prepared the mock for this situation that when we will pass some data or try to execute this dependency on the service class while executing this getHouseById method, then this mocked object will return us some data. And as I said, we can see that there are three parts of this test. The arrange, so we are setting up the mock and the data which will be used inside the test. Then we are executing the code which we would like to test, and at the end we are asserting the data. So we are checking if the data which the method return is the same as we would expect. So at the beginning we have some seeded data, and based on this seeded data we can check that our testing method, our implementation return the data which we expect. And this is how we defined the tests. I think that I can show you one more little thing. When you are writing the tests, each test should cover some part of code. So you should write some, for example, at least one test to check if sending the empty GUID should throw an exception. We should test if the data was not found inside the database, then we should throw another exception. And if the data was found inside this in the database, then we should return it to the user or the outside world. We have some metric that is called test coverage, and we can measure this test coverage and to see if the tests are covering our implementation. As we can see, all of the tests that was defined passed. We can see that each line of the code is covered by the unit test, but I have some small surprise that when I remove this line and we will execute the tests, we can see that some metrics may show you if your code is covered by the test, but these metrics usually will not be able to to show you that to indicate you that the value of the test that you write is good enough to prevent all of the changes inside the code that may happen unintentionally. So as you can see, we are lacking one test that is checking the data which is sent to the method. And I will quickly show you how to write a unit test for that. So we can add new fact. So we are now defining that this get house by ID should throw argument exception when okay, so as before, we are as I said, that when we are expecting some exceptions, we don't have to necessarily arrange anything. We can simply add act statement, and we can pass an empty GUID here, and then we can check even in the same line that our okay, then we will be expecting exception. We can indicate or expect assert that this method will throw exception, and we can indicate what kind of exception we are expecting. And in this case, we are expecting argument exception. And then we have to execute the code that we are testing, because this is an asynchronous code that we have to add some async await here and here. Okay, and now we can check if the test has passed, and if okay, we have success. And for example, we can also assert if the exception that we received has the proper message. So we can assert that our message that we received is equal to the one which we are received, and the most at this stage, the most needed part maybe is that we have to pass the expected value as a first parameter of the assertion, as the name of the parameter for assert equal indicates. First we have to pass the expected value, and then we are comparing this expected value with the actual value that was returned inside our from our result. So we have some information that there's some difference between those values. Yeah, so the message that we received from the exception is different. And one also a good thing about the writing unit test is that you can debug the unit test without running any of the code of the application code, without starting the application to check if your code is working correctly. So usually you start your code and you debug the code to ensure that it's working correctly. You can also run your code and see that it's or debug the problem that you are facing. In this case, there's something wrong with the exception message that we received. Maybe I will not go into details now, but I wanted to show you now. I will remove that. I wanted to show you that when you will remove this line and run the test again, the test failed because the exception that we are expecting here was not caught. Instead, we received the house which we didn't expect it. Okay, this is everything that I wanted to show you. Maybe we have some questions you would like to ask. Okay, in the meantime, I would like to invite you to my second meetup that will take place in 2 weeks. And I will be discussing, I'm afraid that it will be in Polish, but I will be discussing the practical approach to integration testing in the ASP.NET Core for ASP.NET Core Web APIs. Okay, I don't see any questions. The last thing that I didn't mention on the beginning, that the sponsor for today's meetup, Avanade, will send you some gifts when you will, of course, to some selected people who will fill the feedback who'll send some feedback for us will receive some small gift. Okay. Yes, sorry. I will show you the details about this upcoming meeting. If I will be able, I'm not sure if we will be able to add the link to this presentation below the movie. we will try to share the link to this presentation with you.